why did we get into this business? What's so compelling about service robotics? First is that one of the key things in service robotics is infrastructure. Infrastructure is are assets owned by the government and to be supported by the government. There is a $200 billion spend every year that our government makes in just fixing our roads, bridges, pipes, etc. What you can see up here is there's a report card. This report card is issued every year by the Society of Civil Engineers, and it indicates that our average grade on our infrastructure is a D. There is a great need for this. Frankly, over a 5-year period, this group has come out and said we need to invest $2.2 trillion to get our infrastructure up to an acceptable level. And to me, as a business guy, I would sit there and say, okay, that's an opportunity. So what does this mean? How can we go and penetrate service markets and service robotics using technologies that have been developed in universities and developed over the last 20 years? Basically, what we identified was that in pipes, you cannot manage what you cannot measure. So what you see up on the screen here is pipes to you and me, we look at them and say, who cares? Cracks, offset joints, root intrusions, out of sight, out of mind, they're not something that we should worry about. To people, this is their jobs. There's thousands and thousands of people out there who actually, and I never knew I would be such an expert in sewer pipes that I am now, but thousands of people out there that are actually supporting these very, very expensive, frankly, trillion-dollar infrastructure of underground assets. The key thing is that there's no information, there's no knowledge of what's going on with these pipes. There's really a shotgun approach to how do you go about understanding how to allocate, spend, and fix these things. This is where robots come in. This is where the solution comes in to be able to go and fix these. This is what happens when you don't fix your pipes. This is what happens when you're not taking care of your infrastructure. You have critical pipe breaks in Tucson, 38 million, in Michigan for 25 million. I think you're all familiar, you hear about it in the news. Infrastructure fails all over the place. We've recently had a bridge collapse. These are the big scalable structures that robotics is very good at handling. These are things that are repeatable over and over and over. If I can clean and inspect or rehabilitate 3 feet of pipe, I can do all 800,000 miles that exist in the world. So what is this technology? What does field robotics, mobile robotics, service robotics have on the impact of, let's say, this little industry of sewers? So first of all, we need robots to get into these pipes because humans cannot get into an 8-inch pipe. We need to put some sort of technology in there to be able to go and understand what to do and how to fix this environment. Secondly, is that right now we have thousands of people driving trucks around doing camera inspections manually. They're not telling them anything. There's rooms and rooms full of tapes that people use to be able to go and evaluate these environments. We're not utilizing our labor very productively. So how does robots actually help this? So let's look at this and see how this flows through. Firstly, and you can see there's a little robot that's blinking over there. These robots, we have different robots that go in. They go in, they collect this information automatically. Think of it like a Xerox copy for pipes. So first of all, one, you reduce the number of people to go out and collect this information by about a factor of 5. The key is that you don't take those people and say, oh, well, let's let these people go. It doesn't work that way. Those people then change their job to more productive activities. They go out, they fix the pipes. They prohibit the overflows from occurring. They help with implementing the capital plan. So it becomes a much more proactive way to go managing proactive way to manage our assets and our infrastructure than being reactive. So robotics is actually the enabler to be able to get ahead of this problem and for us to really get our costs and spends, our government spends under control. This case study I just mentioned and this pipes is just the tip of the iceberg. Just in worldwide inspection, this is just inspection, it is a $2.5 billion market, about 20% of all of our spend in fixing our pipes. We have to go and understand where it is, what the problems are, and that's where robots really apply. The most compelling thing, and for me, why I'm making service robotics my life work, is that there are huge markets out there that have to undergo the same process that we're doing within pipes. They include agriculture, mining, healthcare, etc. Eventually, service robotics will be larger than the PC industry, and what we'll be able to do is through not just going and doing inspections, we're going to be able to do work and then also extend this to other markets. So let me just kind of review some of the findings from the study. First of all, what is service robotics? Service robotics is going out and building robots, building technology that help people at their home, in work and for leisure. This type of robotics is different than manufacturing robotics. This is typically where you're actually working with people and robots together in a collaborative fashion. We break this up into two divisions: professional service and personal service. Professional service robotics is like the mining and the agricultural robotics and the pipe robotics I mentioned. Personal service is the type of robotics that will occur in your home, like vacuum cleaners and different toys. The opportunities that exist here are vast, like I mentioned before. We've already discussed the aging workforce. Right now, out of your 10 workers, 2 of them are retirees today. By 2030, that will double to 4. We need to make up that extra capacity, and the only way to do that is through automation and through robotics. Right now, the applications are in specialty applications, like the pipes. These are the dirty, dangerous, and dull applications. Over the next 10 years, that's going to shift, and they're going to become more general purpose applications that apply. The obstacles that we're working with is first technical. We need to go and create new technologies, create new ways of being able to go and sense and understand and operate the robotics and technologies. Secondly, we have to build businesses that enable us to go and service our customers and clients and support the unique needs of mobile robotics and service robotics. Lastly, we're up against incumbent players. There are large companies out there that don't have an incentive to bring on new technology. So we have to find ways of working through those incumbent players and the old culture.